Let's solve this physics problem. A small block of mass m equals 0.1 kg is released from rest at point 1 at a height h equals 1.8 meters above the bottom of a track, as shown in the diagram. It slides down the track and around the inside of the loop of radius r equals 0.6 meters. The speed of the block is 2.5 meters per second at point 3. Which of the following claims about the situation is correct? So instead of showing you all the correct situations, we're gonna solve straight for the correct situation, and then I'm gonna show you the correct answer. So let's see here. The height is 1.8 meters. So let's go ahead and label that. And the energy at point 1 is only gravitational potential energy because it was released from rest at point 1. So the energy at point 1 is equal to, and recall that the formula for the gravitational potential energy is mgh, and we're going to say at point 1, so h1, so which is equal to 0.1 times gravity, will use 10, and times 1.8, so that we get 1.8 joules. That's the total mechanical energy. Now let's look at point 3, since we are given that it's 2.5 meters per second at point 3. So at point 3, the total mechanical energy, we'll say, is equal to, now at point 3, it's above the ground, so there has to be gravitational potential energy, but the block also has kinetic energy sliding down this hill. So it will be, the total mechanical energy will be 1/2 mv squared plus mgh, as it also includes the kinetic energy and the potential energy. So solving this, we'll get 1/2 0.1 v 2.5 squared plus m 0.1. We'll use 10 for gravity again, and height at 3, which is 2r because radius, and the radius is 0.6 meters. So 0.6 meters times 2 is 1.2 meters. So from here to here, it's 1.2 meters. And we'll put that there. And we get, calculating this, we get 2.5 times 2.5, 6.25, 1/2 times 0.1, 6.25, plus 0.1 times 10 is just 1, 1 times 1.2 is 1.2, and doing all this, we get the mechanical energy is 1.5, approximately 1.5 joules. Now we see that at the start we had 1.8 joules, and at point 3 there's only 1.5 joules. So there has to be some work or dissipated energy of 0.3 joules. So that's why this claim that the mechanical energy of the block Earth system at point 3 is less than the mechanical energy of the block Earth system at point 1 is correct.